Hi, my name is Donghan Hu. Today I'm going to present our paper. The title is ScreenTrack, using a visual history of a computer screen to retrieve documents and web pages. Interruption is inevitable for modern knowledge workers. It can happen everywhere at any time, like unexpected interruptions from your colleagues or email notifications from your phone. In this cartoon, we can see a programmer is thinking about algorithm, but then he's interrupted by others. All these efforts are lost in a sudden. After interruption, we need to resume the unfinished task, and task resumption takes time. Therefore, interruptions and task resumptions are problems in improving productivity. Task resumption is not easy. There are two different challenges in task resumption. First, I need to remember what I was doing in the past. I was reading, writing, or just brainstorming. Second, where is the document that I was doing? Was I reading a paper on the Chrome, or I downloaded it and read it on the Adobe Reader? Because there are many applications we use, and there are also many documents per application. Current applications have functions that help users resume previous tasks and reopen the documents they used before, like browsing history in a web browser. But here is the problem. All these URL and titles are not efficient enough to help us recall and resume tasks. For example, look at the first one. I'm really confused. Is this the paper that I'm looking for with this information? The title is just meaningless numbers. Another problem is that computer activities history is stored across different applications. If I forget which application I used to open a specific document, I may spend lots of time on reviewing each history list. Also, one may use many applications to resume a task, so connections among documents in different applications will be lost in the per application histories. Here are several examples. Based on these challenges, here are the motivation of our paper. We designed and developed an application that facilitates task resumption for both mental reconstruction and document retrieval. This application has a single history of computer activities for multiple applications, a feature to relaunch different software and close documents. And eventually, this should be a less time-consuming method than existing functions. Our main approach in this paper is utilizing visual history, providing not only textual cues, but also visual cues in temporal order about past computer activities for users. A number of researchers find that watching visual cues can help people reconstruct mental context accurately. Watching recorded video is often used as a usability test method as an alternative to think aloud method. These images are taken from previous researches that utilized visual cues to help users recall, retrieve, and remember. Drawing ideas from existing work of visual history, we designed and developed our application, ScreenTrack. ScreenTrack can help users resume tasks by providing a time-lapse video of their computer screen and letting them reopen documents from the snapshot. This is the main user interface of the ScreenTrack. We can see on the left side, it looks like a normal media player which can display time-lapse video. While on the right side, user can review related information at the same time based on the left image. User can simply click this open button, here, this one, to open the application and documents, also the web pages, which are shown in the screenshot. Now let me show you a live demo of the ScreenTrack. The first interface is configuration window. Users can input time interval, like take a screenshot each 3 seconds, day length 10 days, and whether they want to save compressed screenshots to save the disk space, this slider. By clicking this button, the main user interface will show. Let me go to this one. This is a short recording of my past computer activities. I can watch it like a time-lapse video by clicking this player button. And I can also change the play speed if you think the player speed is kind of too slow. Drag the slider to anywhere you want, or you can just click these buttons to review images one by one. Once I find the image that I'm looking for, I can click this button, the open button, and the ScreenTrack can open these web pages or this document automatically. Let's suppose that I recall the cover of a book that I want to purchase, but I don't remember the exact name of that book. So I can review these images and directly open the specific web pages through ScreenTrack, like this. This is the same web page. These are our design goals for ScreenTrack: presenting visual cues, cross-application retrieval, privacy concern, and disk space usage. ScreenTrack stores all images locally without connecting to the internet, and it can automatically delete images which were taken many days ago to save disk space. And it can also provide users with information about how much disk space it will take according to users' current setting, like this one. It's about 20 gigabytes for users if they want to take screenshots for each 10 seconds and store them for 10 days. We asked 3 research questions in our paper. Does ScreenTrack reduce time for retrieving compared with existing methods? What are users' perceived values and concerns? And how ScreenTrack spot users for task assumptions? We conducted 2 user studies to answer those questions. The first user study is about web surfing and retrieving previous closed web pages. For the second user study, we asked participants to create a presentation slides for making travel plans. During this study, we interrupted the task and asked them to revisit the lab after 48 hours and to resume previous unfinished tasks. Let me explain each study one by one. For the first user study, we recruited 20 participants, and the average age is about 26 years old. This user study takes about 1.5 hours per participant. Here is the procedure of user study 1. Participant is asked to surf furniture web page to pick their favorite furniture. We had 2 conditions. One is control condition, means without the ScreenTrack. And the second one is experimental condition, which means that user can use ScreenTrack. After 25 minutes, I asked participants to reopen their favorite furniture web page in 2 different conditions. And now this is a screenshot from one participant's recording in experimental condition. This participant find his favorite sofa, like this one, white one, on this page, and just simply click the open button, like this one. Then the page was opened automatically in a short time. This action took only about 1 to 2 seconds. Next, I will show the results of the user study 1. ScreenTrack is more efficient. Participants spend less time with the help of ScreenTrack to reopen their wanted web pages. It is 27.1 seconds compared with 42.9 seconds, and there is about a 58.3% gain in productivity. We then further look into data. We find that participants are getting faster over trials. 16.4 seconds spent in the third trial is faster than first trials, in average about 38.1 seconds. This shows that ScreenTrack has capability to improve users' performance about retrieving information. How participants use ScreenTrack? We find that participants used all 3 different methods for retrieving digital resources. Different participants preferred different methods, like slider, button, and replay function. and they got gradually more preferred using the slider to help them quickly locate those wanted images, like drag the slider to the left or more or right. From the interview part, we can see that ScreenTrack is easy to use and intuitive according to the feedback. Like what P4 said, it is easier to use, it follows a chronological order, and it can direct me right to the web page. What is more, participants consider that retrieving digital resources across applications is helpful, just like what P5 said. So with this tool, I think I can save lots of time to select, to find files that I want to even across many different applications. Another finding is that participants are concerning about privacy problem and disk storage problem. They worried about their personal information is stored securely or not, and storing too many images is not a good way for their computer's disks. Now let's move on to the user study tool. In this graph, it shows the procedure of user study tool. We recruited 8 participants this time, and we asked them to make travel plans for 2 different places, LA and Hawaii. We still have 2 conditions this time, control and experiment. But the difference from user study 1 is that we set a time interval which is at least 48 hours between 2 visits. This is a longer term in the task resumption experiment. Now let's look into the result of this user study. In this study, we consider overall resumption time includes file finding, open, and initial editing in this file. And the result shows that participants who use ScreenTrack spend less time in overall resumptions. We can see that those 4 participants have the shortest resumption time with ScreenTrack compared with others who didn't use ScreenTrack, like the first 4 in this red rectangle. The time is much faster than the others who didn't use ScreenTrack to help them. This is a screenshot from one participant recording. The participant can recall what he was doing and thinking in the past with the help of this image. For example, not only a participant reopened the web page from the ScreenTrack, this web page reminds them that the trip needed to be kid-friendly because it's a family travel. Then he can continue his previous unfinished working starting with this information. That's our results for our 2 user studies. Here is the page of limitation and future work. We still need to design medium or longer term user study in the future, like maybe more than 3 weeks. We still need to test heavy workload tasks for ecological fidelity. Now 2 studies are both in lab studies. We are going to distribute this application to participants for daily work. At last, we still need more efficient method to protect users' personal information and consider more about the disk storage space. And this is the research contributions of our paper. We provide an idea of using video history to help people retrieve digital resources. We designed and developed an application ScreenTrack to achieve design goals. And we also use quantitative and qualitative evidence to demonstrate the effectiveness of our system, ScreenTrack. And that's all. Thank you.